Good morning, guys. In today's lecture, I'm going to talk about while loop structure, and we're going to solve some questions, hopefully, with while loop. As I said, you can find all the information about the loops in the course page. So I did a video. So if you go to the Introduction to Computer Programming course page, there's a YouTube channel. Every week before you coming to the class, right now these were recorded as optional classes at first, but given the circumstances here, this is how I am doing the classes right now. You got to watch the video every week before you coming, and we're gonna do the lecture based on these videos, based on the questions you do not understand, based on the topics, because currently as you can see, there is no we cannot communicate to one another, so I cannot know what problems you might have with the course material. So this is the only approvable, let's say, official way that I can contact you. Hence why it's utterly important for me you to watching the videos before you come. Otherwise, if you do not have any knowledge about what's going on, I will come here, end up solving the same or similar questions, and just gonna, spend even more time to fix up the issues that I already discussed in the videos. So before I start giving you, solving a couple of questions in here, do you have any questions about the previous courses, such as if else, conditional statements, or operators? Any questions before we move on further that you would like to ask? You can ask it by talking. I can unmute you. If you have any questions at any time, please raise your hand on the participant window, not on your webcam. On the participant window, there's an option for you to raise your hand. And you can also ask questions through the Zoom chat as well. So, any questions? No questions. Wow. So everything is clear. Okay. So let's go to the page of our course. Find the some of the exercises in here. So this week I'm doing loops, so I'm gonna unlock the chapter 4 on Moodle. That is the topic that I'm covering today. So we have, after loops, 2 more chapters, and hopefully we'll be done by the course. I'm just gonna maximize this to discuss a little bit further about the loops. So a loop structure is a programming construct, as I discussed in the videos. This is a statement that allows you to operate a series of instructions, usually until a certain condition is met, or you kind of like reach to an upper limit in a conditional structure. More often than not, we use a logical comparison statement in a loop structure, such as greater than, less than, equal to, not equal to sign. And we can also combine 2 or more statements, just like we did in the condition control structures in if-else part. You can combine them with and or not. So all of these are possible. These comparisons eventually result an expression to come up with a true or false. Hence, the loop condition can only be, just like the control structures, true or false. There are no alternatives. There are 3 main loops that we will cover throughout this course. The first one is the while loop. So with while loop, this is the one that we use in the flow algorithm as well. It is basically used to describe the loop structure. It is actually a control loop, which means that it will check up the statement, the control structure first, and then it will execute the condition. That is called a control loop. There are also two other loops that we will hopefully cover throughout this course. One of them is do while, the other one is the for loop. Now, with the while loop, when you iterate the components, they are usually written down on different lines, such as the initial statement is written down on a line, and then the condition is on another line, and then the iteration is on another line. So each one is placed on different lines usually. So there is the while expression, there is the increment or decrement structure, changing the loop content, and finally the initial number. All of these are written down in different places. Just like in the control structures, the brackets are only compulsory when you have more than one line. So if you only gonna execute one line, then you don't need to put the brackets. But usually you have multiple lines to execute, hence why you will need to probably to put the brackets when you create a while loop. So when you look at these structures, you define a condition in the while loop, as you can see, with all these statements that I listed. So you use at least one of these statements in here, and you create a while loop. And then within the while loop body, which is the brackets, you define a condition which will always change. If you do not define the condition that will change constantly, this will create what we call as an infinite loop. An infinite loop is not a good practice. It is not something that we encourage. So, especially in traditional programming. There are ways, there are places that infinite loop is very useful, such as in most game programming, especially when you create these small game structures. A while loop, an infinite while loop, or any loop that is infinite can be very useful because it represents the flow of time or the active time of the game. So it could be very useful to understand, the user interactions. But for traditional programming, the ones that we are doing, that we solve business or mathematical problems, an infinite loop is not a good practice. So at some point, you need to make sure that the loop stops. Otherwise, this will create you some problems, and it will not be very useful to you, because then the exit structure of the loop is not going to be defined. So let's look up this example in here. As you can see from the example, there's a while loop structure, there's an initial statement, there's a while loop structure, and there's a body. So when you write while loop, there are three important places that you must pay attention. The initial statement, which is where the while loop will start. The body, this is where the upper limit will stop. So this means that it will start from 0, go up to 5, and it will only run as long as it is less than 5. And with each statement, you show a hello world and increase the counter. This means that the count is 0. 0 is less than 5, so it's true. It will come there, show it, increase this as number 1, so that it will be 1. And 1 will go up and check it again. 1 being less than 5, it will execute again. That will become 2. 2 being less than 5, execute again. 3 being less than 5, execute again. 4 being less than 5, execute again. And finally 5. 5 is no longer less than 5, so it will exit the loop structure. So you will have 0, 1, 2, 3, 4. Totally 5 hello worlds will be displayed on your screen. So why do you use loops? Well, the main reason is sometimes you do processes that are very repetitive. They are the same thing, such as adding numbers, multiplying it, such as every student in our class, for example, they will take a quiz. But regardless of these people being different, they will all be treated the same because they will all take the quiz. So it's a repetitive process. Most of the time, what we do is when we deal with the set of data, is a repetitive process that we apply to every single one of these data in the set. So in those conditions, it is vital to use a loop structure rather than repeating the code. Because in programming, repeating the code is regarded as a bad practice. If you have two programs that are doing exactly the same thing, but one program is doing it with 20 lines, where the other program is doing the same thing with 50 lines, then the program that has 20 lines is the better one. In programming, the less number of lines you have to perform a task, the better the program is. It is more optimized. So hence why, instead of repeating these statements in the program body, what we do is that we create a while loop so that we can repeat them in the loop structure. Do we have any questions up to here? Can you please respond, guys? When I ask you a question, you can also talk or respond to me. Otherwise, I'll be just talking to myself. Thank you. So you don't have any questions. Good. So in this loop structure, you can see that you can write this in different ways. In the previous example, we wrote it as 1 to 5, so 0 to 5, hello world. And in here, in the example, 1 to 6. So it doesn't matter if you start from 1 or 0, or even you can start from 50 and do the opposite. And in here, you can see that it started from 1, go up to 6, and each time it showed the number. So the number increased each time and it showed it. So first it was 1 less than being 6, show the number 1, increase it, 2, 2 being less than 6, 2, 3, 4, 5, 6. When it becomes 7, it is no longer less than or equal to 6. So it jumps automatically to the end, which is return 0. So when the condition is no longer true, it doesn't execute it. It exits to the next line, which is the line after the curly brackets. That is the core structure of loop. So let's solve a question in here. Write a program which will display integer numbers from 77 to 1 on the screen. How can we do that? Some of these questions, as you might realize if you open the presentation slides, they don't actually have answers. So that means you are supposed to solve them yourself and approach us and say, if you get stuck, oh, I couldn't solve exercise, let's say 7, so that we could discuss it together. And this is why we have these sessions. You need to approach me and ask questions, okay? Because everything is covered in the presentation slides, also in the videos already. So me coming here and repeating the same thing doesn't mean anything. These sessions are specifically set up for you to approach me and ask questions, okay? Don't forget that. I am going to solve a couple of these questions, and then see if you have more questions. So let's start with this one. Write a program which will display integer numbers from 77 to 1 on the screen. So first thing I'm going to do is to create a new program in Dev C++. So setting up my screen and saving my program. I'm just going to call it loops exercise. Which one is that? That's exercise 3. In slides. So let's get started. First thing first, I'm going to put the standard statements. Cin is optional, it's not compulsory, so even if you don't put these lines, it should work just fine. They're completely optional. And let's start with the program. It says that it starts with, as you can see, it says that it starts with 77 and goes to 1. So it's kind of like the opposite now. So whenever you create your counter, we'll go in here and say that the counter is actually 77. Instead of defining this 1 or 0, we will do an opposite, a reverse kind of way to list the numbers. So once we have done this, we need to make sure that the while loop we're going to write for the count would be greater than or equals to 1. So this means that as long as the count itself is greater than equals to 1, do the followings. So that is the meaning of this statement. As long as count is greater than or equals to 1, do the followings. Okay, that is the meaning of the statement. And once you have done this, you can actually display it. Let's display each number on a new line. I think you can put it with n line as well. So just put the count and L, which will end the line itself. So you show the count. But if we do this now and run it, it will always show 77 because we didn't do any change. So let me just save to show you how it's going to run. It will always show 77. And you actually create an infinite loop. This is not what we wanted. We wanted the numbers to decrease. And the reason why this happened is because you never manipulated the state of count. So essentially, you should either increase or decrease the count so that it will reach to this point. Currently, it's 77, and because 77 is always greater than 1, it creates an infinite loop structure. However, when we come there and say minus minus count, each time it executes this now, it will decrease it, and eventually it will reach to the point where it will be less than 1 now. So it will stop. So running this application now, you can see that it started from 77. It started from 77. And if we go down, we'll see that the final value it shows is actually 1. And once it reaches to 1, which is greater than equals to 1, you can see in here, greater than equals to 1, it stops there. Because once it is less than 1, it will no longer execute. Any questions? Good. So let's go and look at the other exercises in here. In one of these exercises, it says that write a program which will display the following integer numbers by assuming n will be entered by the user. Now, this is a very interesting one. I think I showed something similar in the video as well. So I'm going to solve this one in here. So what we're going to do in there is that instead of these numbers to be fixed, we're going to ask the user to enter them. So I'm going to define a number and ask the user to enter it. Please enter a number. You take the number, and instead of starting from 77, we're going to define a count again, but this time the count will be 1. And it says in here that it will increase and show odd numbers such as 1, 3, 6, 9, 12, and so forth, up to the n number, which is the number n is entered by the user itself. So this time when we put the count, we're going to say as long as the count value is less than or equals to the number. So we're going to create the logic that as long as this count number is less than or equals to the number. Now we're going to show the count number with each value, but instead of decreasing it, we're going to increase it. One way of increasing it is actually putting 2 more. Because if you add 2 more each time, 1 will be 3, 3 will be 5, 5 will be 7, 7 will be 9, and so forth. This is not the only solution for this specific question, but it's one of the solutions that you can show. And if you want to show them each line, we already written down the statements in here, you can show it. So let's just execute. The program starts and it asks me a number. So I'm going to enter a number in here. Let's say 36. And as you can see, it starts from 1, 3, 5, 7, 9, 11, and goes and shows up every single odd number on the list up until to the point of 35. Now it doesn't show 36 because 36 is actually an even number. It's not an odd number. So if I actually run this thing again, but this time I enter an odd number instead of an even one, it will show that specific number at the end as well. You see? The 1, 3, 5, 6, 7, 9, and it goes down to 21. It shows all the numbers up to that specific number. This is not the only way to solve this question. There could be more than one ways. In most cases, you will have more than one approach to solve the questions. So you can count the number and show them, but you can also say something like this. If the count itself is divisible by 2, but the remainder is 1. So if you divide the number by 2 and you get the remainder 1, you kind of like then only show it and increase it 1 by 1 each time. Instead of increasing it 2 by 2, you increase it 1 by 1, but only show the ones that are divisible by 2 and you get the 1 as the outcome. So entering another one, let's enter 26. And as you can see from the results, more or less what you get is exactly the same. 1, 3, 5, 7, 9, and 11, 13, 15 up until 26. So that is the core structure of while loop. There are many questions on there that you can see. and you can achieve to it. You can also create the same kind of system using for loop. Now, before I move to for loop, I would like to stop in here, and I'm gonna re-invite you to another session because I'm almost running out of time right now. So I'm gonna send you another invitation on Big Blue Button, because every invitation that I send must be under 40 minutes. Before I move to the for loop structure, do you have anything you want to ask me about while loop? Because I basically finished while loop. That is the core structure of while loop. So if you want to ask any questions, this is the perfect time. Okay, you don't have any questions. Very clear. Very good. So please go back to Big Blue Button right now. All right. I will send you another invitation, because in Zoom, every single invitation we have, every single conference we have must be under 40 minutes. Okay, that is the rule. So please go to Big Blue Button and I will send you another invitation so you can join. See you in a while.